What? I did start streaming. I'm so sorry. Cool. I'm a bit scared. Um, this should start now. Has it not started? Yes, it has started. Um, I'm just going to see on the link, the YouTube link that I have shared. Cool. Okay, damn it. Okay, so cool. We are live. I'm so sorry for my camera quality. Okay, that is going to be resolved in like 2-3 minutes after I move on from the introduction part. Okay, don't worry about that. And I am just going to keep the stream here so that I can see exactly what's happening in the stream. Um, okay, good. Let me just keep this here. Oops. Yeah. Okay. Uh, I have to start, right? Yeah, let's start. So I know why all of you are here. I hope you guys know why all of you are here. Today we are going to do a robotics lesson where we are going to learn how to build and code your own robot car that can follow a specific path. We are going to. It says part one in the posters that we have circulated. It says part one because we are going to start by building a robot car that can follow a specific path, by building and coding a robot car that can follow a specific path. Is my audio clear? If my audio is clear and you guys are able to understand me, if my volume is okay, then send a W in the chat. Okay. And yes, a lot of you are asking, is it going to be on HatchXR or is it going to be a real life robotics car? So it's going to be a real life robotics car, okay, a proper 3D car. We're going to build a proper 3D car and code it. But to those who won't be able to access the parts that I show you in this course, I'm also going to show you how can you do this in HatchXR as well. You can build your own VR robot car in HatchXR and code that as well. So stay till the end of the video and I will show you how you can do the exact same thing I show you. Yeah. No, just W was just for me to know that you all are able to hear me clearly, and I got that. So you guys can stop sending W. Okay, good. So as I was saying, we are going to start with building a proper robotic car, and code the car to make it follow a specific path. Once we are done with that, by the end of the video, I will also show you how you can do the exact same thing I show you uh, with the robot car. How can you do that exactly on HatchXR as well? So even though you are not able to build a robot car in your home, but you should be able to code a robot car on HatchXR and make it move. Okay, so let's get started. I am going to start with this. So now you should be able to see the setup. These are the parts that we are going to use. Okay, and I just hope everybody enjoys the video, learns something, and oh, wow, I am kind of nervous. I'm also nervous. So this is the first time I'm doing. This is the first time I'm doing something like this in a class. So good. Let me just see if the scene is popping up once. We are not. I will send you the cool. Yeah, I can see that you guys are able to see the parts. Okay. So first of all, we are going to learn how to build, what we are going to build, and then we are going to start with, and then we are going to code. So I will, when everybody's asking to send the link of where we are going to code, I will show you guys that. Don't worry. I will show you guys where we are going to code and how we are going to code. So that will come later on at the second half of the video. All right. And yes, we are now going to. So you can see all the parts here. So let's start from the very beginning. What we are going to build, how we are going to build, and how we are going to code. Okay. So you can see I have some parts here. I will tell you guys how everything works, what we are going to use all of these parts for, and I think I'm just going to yes. Okay, yeah. So this I should be more clear in the video. Okay, cool. So these are the parts. What are these things, and what will you guys need? Okay. So as you can see, first of all, we are going to learn how our car is going to look like. What is our car going to look like? So right now, I already have started with a small piece of cardboard. So this is a piece of cardboard, a stiff cardboard. You guys can take a piece of 20 centimeter by 20 centimeter metal. Don't worry about the slots cut here. Yeah, you should be able to see the parts here. Good. So you don't worry about not having any of these parts. That's what I'm saying. You right now, I will show you how to build a proper robots car so that in future you can get the parts and code along and work along. But if you don't have the parts, stay till the end of the video and I will show you how can you do the exact same thing I'm showing you right now on the Hatch workspace. All right. So just follow along. Just watch me, follow along, and you can again rewatch the video whenever you are able to buy the parts. These parts are going to come along very cheap. On Amazon, you can find everything I'm showing you here on Amazon or on any of the local electronics store that you might have nearby your houses. So you can get all of these. So I have already started with a basic setup. So I'll start with, I'll tell you what I have. So first of all, the parts that we are going to need. Okay. So I'm just going to write on this. So we are going to, first of all, one, design how our car is going to look like. Okay. So first we need that. Is this legible? Is this visible to everyone? I'm not sure. Okay, cool. Guys, if you don't have parts, don't worry. Everybody's asking about the parts. If you don't have the parts, don't worry. Watch till the end, and I'll show you how you can do this in other ways. Okay, so design. So as you can see, just we're going to start with a piece of cardboard, a piece of stiff cardboard or acrylic or metal sheet. You can have it around 20 centimeters by 20 centimeters. Okay. Wow. I'm just going to zoom in. Yes. I hope this thing is visible. Yes. So we are going to start with a 20 centimeter by 20 centimeter piece of cardboard. So as you can see, I have something similar with me here. Now, we are going to use two motors. So these are called DC motors. Motors, so I have another sample here. So this is a DC motor. I'm just going to focus on this. You're going to need two of these. Okay. So you're going to need, yeah. So we are going to use two of these DC motors. Now, what does the DC motor do? A DC motor, you can see it has two wires coming out. Both of these motors here as well. They have two wires coming out. Okay. So now, what happens with these DC motors? You give them power. Okay. You provide electricity supply to these motors, and then what happens is you can see this rod coming out here. This rod rotates at a very high speed. So a motor takes an electrical energy and it converts that electrical energy and provides you with a mechanical energy. So you can use electricity to do some kind of mechanical work. Okay, that's what a motor is used for. Similarly, you guys must have heard of generators. What generators do is they are the complete. Sorry, I got disconnected. I'm so sorry. Um, yeah. So what does yes, yeah. So what does a generator do? A generator takes in mechanical energy and it converts that to an electrical energy. Okay. Generator is completely opposite of motors. Now, so DC motors, you will need two of those DC motors. And what I have done is I have screwed those DC motors here, okay, uh, side by side, so that they have these rods coming out that on which we are going to attach our wheels, and that is going to make our wheels move. So I have two wheels here. You can get all of these on Amazon. I will attach the links of where you can get these on Amazon, or if you just go to a nearby electronic shop, you'll be able to get these. Okay. So I have these two wheels here. So let me show you how does a motor work. Okay. So you see, I have. I'm just going to these are the wires coming out of the motor. I'm just going to attach these wheels to my motor here. Um, yeah, I have the motor and I have the motor. I have the wheels here. Okay, cool. So my wheels are attached. Now you'll see I have some batteries here. So before we attach these batteries and understand how these batteries are going to affect our motors, I just have a simple single cell battery here. What I'm going to do is, so we need to find out which of these wires are going to need positive supply and then are going to be is going to be connected to the positive terminal and going to be connected to the negative terminal. Okay. So what I'm going to do is I'm just going to connect these wires. So I'm just going to show you. See, I'm just connecting connecting the red wire to this terminal of the battery. Okay. And I'm going to connect Uh, so I'm using double-sided tape. You can get this in any hardware shop as well. So you can use screws to attach your motors and wheels and everything. I use double-sided tape because they are easily removable. So and they are easy to as in assemble and disassemble. So I'm just going to connect this black wire here, and you will notice that my motor will start moving. Yeah, see? 1 second. Yeah. So now I know that for this motor here, for this motor, you can see the wheel is moving. For this motor, if I connect the red wire to the positive terminal of the battery and the black wire to the negative terminal of the battery, then this wheel is moving in clockwise direction for me. Sorry, anti-clockwise direction. So if this is going to be the front of my car, if this is going to be the front of my car, then red to the positive and black to the negative is going to make my car move forward. Okay. So you do the same thing for the second motor, and you will know that red is. I know that for both of these motors, red is going to make the wheels move forward for this side of the car. Okay, and then if I just switch the polarity, if I connect the black one to the positive terminal and the red one to the negative terminal, the wheels are going to move backward. Okay, so I'm just going to keep this away. We don't need all of this. Okay. So, yeah, so I was talking about the design of a car, of how our robot car is going to look like. So, we at least need two motors and two wheels. Okay. Now, you can also design your car using four motors and four wheels. You can do that as well. But what I'm going to do is I'm just going to use two motors. And with these two motors, I'm going to attach two wheels here, and I have another small wheel here. It's called a caster wheel. Okay, so I'm using a caster wheel here because I don't want to attach two more motors. So this is going to level up my car here. You can see that my car is leveled up, and then the caster wheel doesn't need any motor attached here. So I'm just going to put these wires on the, oh, come on. I'm just going to put these wires on the opposite side. Cool, on the top side of the car. So now I know that this is going to be the front of my car. This is going to be the front of my car. Okay, and uh, when the both of these wheels move forward, when the motor is turned off, both of these wheels turn, then this is on itself, this wheel is going to move forward and move my car forward and keep it stable. So I don't need two more motors for two more wheels. We're going to start with basic two motors, two wheels, and one caster wheel. And later on, if you're making some advanced robots, you can attach as many motors as you want. Cool. So yeah, basic design, two wheels, two motors attached to a piece of metal, a piece of acrylic, a piece of cardboard, and a caster wheel. Okay. Now, other than that, what do we need? So we need something that is going to move our car, that is going to tell our car to move forward, backward, turn left, or turn right. Yeah. We need basically a small computer. So for that, we are going to use something called an Arduino. This is a very delicate piece of circuit. I'm just going to focus it up for all of you guys to see what this is. Yeah, okay. So this is basically a small computer, okay? It's a very primitive computer. It's a very small computer. And what it does is you can write code on it that it will, once you give it a power supply, it will run that code and tell your car where to move. Okay. So as you can see, it has all of these, yeah, as you can see, it has all of these pins here, all of these pins, and all of these pins, you can see they are numbered. I just hope I'm going to focus more. I'm going to zoom and focus. Yeah. So you can see these pins are numbered. First of all, while handling these circuit boards like this, you can see all of their pins are exposed at the back. All of their pins are exposed at the back. Do not ever put this on top of a metal surface. You're going to short all of these pins. Okay, these are very delicate pieces of circuit. You have to hold them by the side or put double-sided tape at the bottom of it so that you never short it by mistake. Okay, hold them by the side always and just use them carefully. Now, as I was showing you, these pieces, they have, you can see the all of these ports, they have numbers written on them. So the ports are numbered and we can use these numbers to tell our Arduino what which part is connected to which port. You're going to connect those motors. You are going to connect those motors. One second. Yes. So you're going to connect these motors to your Arduino, and your Arduino is going to tell your computer, your car, where to move and how to move. Okay. So I'm going to keep this down. We are going to need batteries. So Arduinos need at least 9 volts to 12 volts of batteries. So I'm using 6AA battery and a battery supply thing that is connected to a jack here. This jack can connect here to our Arduino and supply power. So each of these cells are 1.5 volts. That is going to give your car 9 volts of power. Okay. And then you will notice that I have some wires here. These are called jumper wires. You're going to be able to get these on any store as well. So there are different types of wires. You see some of them have these pins and some of them have these ports. So these are called male ports, these are called female ports. You can have jumper wires from male to male port. You can have jumper wires from female to female port. Or you can also have I might be having some, I'm not having those here, but you also have wires that are male to female ports. And you can use those to expand your circuit and connect the wires however you want. Okay, so we are going to need some of these wires. I'm going to put those on the side. Other than that, what we are going to need is whenever you use motors, your Arduino cannot directly communicate to the motors. You need something called a motor driver. Now, motor driver circuits are very common. You can find them anywhere you want. Okay. You can find them anywhere you want, and good. So yeah, you can find them anywhere you want, and you'll see motor driver circuits. They're also having pins that are numbered, and they can be easily attached to an Arduino. They always come around Arduino sizes, so you can easily attach them, and then just remember the number. So each of these pins here are also numbered, and the Arduino's ports are also numbered. So you just have to remember uh, what pins of these motor drivers are attached to what pins of Arduino. Okay, that's all you have to be careful about, and then you will be able to code your robot car. So what happens is your Arduino is going to give commands to the motor driver to turn on and off the motors, to turn on to make the wheels rotate. Okay, and one last thing that we are going to need. It's already 7:20, so I'm just going to start running a bit faster. So yeah, uh, we have the motor drivers, we have Arduino, we have battery cells. Yes, we are going to need this. Now these, I'm just going to put these away. We are going to need these. What are these? Your car cannot see forward. Okay, we are going to code a car that can find the path, detect the path, and follow the path. So I have on this table here, I have a path laid out, and I want to write the code so that my car automatically finds the path and moves along the path. Okay, but my car does not have eyes. We have eyes; we can see that this is the path, so it has to follow this. But cars and robots don't have eyes. How will I make it see the path? We are going to use these things called IR sensors. Okay, these are called infrared sensors. Okay, as you can see, I'm just going to zoom in again to them, and I'll show you what these are made of, how they work. Yeah, so you will see that this is called an IR sensor. IR sensors are used in a lot of circuits. You can make an IR sensor of your own if you want, but you will notice that it has two diodes. It has two of these things. You see, this transparent thing is an IR diode, and this here is called a photodiode. Okay, so what happens is your IR sensor, you are going to place this. Yeah, so we are going to place this IR diode on our car like this. We are going to use two IR diodes that are going to be placed in front, and they are going to act as our eyes. Why? Because what does this do? The IR diode here, it keeps on firing infrared light. Okay, it's infrared light is something that your eyes cannot see, but it's basically light of larger wavelength than a red colored light. Your eyes cannot see it, but they exist. So it continuously keeps on firing infrared light, and then what happens is anything you see, anything that has color, like this is white color, this is black, this is blue, this is yellow, anything that has color has the color because it reflects that colored light. Light has multiple colors. Okay, so like you see, this is yellow. It means that is everything on focus? I don't think everything is on focus. Yeah, okay. Yeah. So if this is yellow, it means that it is reflecting yellow colored light and absorbing all the other colors of light. Okay. Similarly, if this is green, it means that it is absorbing all the other colors except for green. This thing is reflecting the green colored light. That's why our eyes see this object as a green color object. Okay. White means it's reflecting all the colors. When all the colors are combined in light, they make white light. Okay. And black means it's absorbing all the colors of light, all the wavelengths. So what's happening is when an IR sensor, what happens is when this fires light beams, uh, and then if it's looking at a white surface, then white surface is going to reflect back all the light that is fired by your IR, this IR diode. And then that reflected light is going to be detected by your photodiode. Photodiode detects the amount of light reflected that is coming to it. Okay. So for a black surface, no light is going to be reflected, so it will not detect any light coming back to it. And for a white surface, it will be able to detect some light coming back to it, right? So that is how my IR sensor is going to be able to detect whether it's looking at a white surface or a black surface. And then depending on the data it receives, we will be able to tell our motors to move forward, turn left, turn right, or move back. That is how our car is going to work. Okay, so let's start. So we are going to I'm just going to be using double-sided tape as I told you guys. So I'm going to start with connecting IR sensors to the front of my car. So I'm just going to attach this tape here. Yeah, and I'm going to, okay, cool. So I'm just going to tear off this section. Oops. Okay, cool. So I have the tape attached here. I just want to ensure that the diodes are facing down. Okay, so I'm going to attach a diode, an IR sensor here. Yes. Okay, and I'm going to attach. So I have four of these. I'm just going to use two, and I'm going to put the rest of it. Okay. So I have this and this. So make sure that they have some distance. You can use multiple IR sensors. I'm just going to use two IR sensors right now. So I'm just going to show you how to make a basic path following robot. Okay. After that, you guys can make advanced ones by using multiple sensors, multiple motors, however you want. Okay. So these are attached. Now, anything that is an electronic circuit needs some power to run. So you'll see that both of these IR sensors, they have three pins. Okay, let me focus again. Okay, let me just use a different one here. Yeah, so an IR sensor, yes. So you'll see that an IR sensor has three pins. Okay, so two of these pins are where you supply power to it. Anything that is electronic needs some electricity to run. Okay, so you have to supply positive and negative power. So pins are always numbered, pins are always labeled. Any circuit that you get, their circuits are going to have a serial number that you can search on the internet and find out their diagrams, which pins are what. Okay, so but then it's written here as well. So the first pin is where I need to supply power. The second pin is the ground pin, and the third pin here is where I get the data of the amount of light received by my photodiode. So pins are going to be crucial. You have to remember which pins are what. Two things attached here to IR sensors. What we are going to do is we are going to uh, I'm just going to attach the battery source and the Arduino on top of my board here. So again, I'm just going to use double-sided tape for now and place one here and place one here. Okay, cool. I'm so sorry about yeah. Oops. Cool. Mm, I'm just going to remove these and yeah, got it. Cool. So now I need to connect my Arduino. I'm going to place my Arduino here. I'm just going to stick it to this one. And I need the battery source for my Arduino. I'm just going to connect those here, just ensuring that they don't restrict my wheel's motion. Okay, good, cool. So this is going to supply power to my Arduino. Now, what else do we need to connect? We need to connect our motors and our IR sensors to the Arduino. So first of all, we are going to place our motor shield because motor shield is going to communicate, get the data from the IR sensor and then tell our motors how to move. Okay. So to do that, what we're going to do is I'm just going to place this. So remember the numberings. So I know that we know the numbers here, and this motor shield has the same numbering of pins as this Arduino. So I know that the pins here are numbered 0 to 7, and here they are numbered from 0 to 7. So I'm just going to connect them accordingly. So I have, yeah, it's going to go like this, and it's going to fit here. So you can see motor driver is connected to the Arduino. Okay. Good. So now you will notice that motor shield has these four pins here where I can attach my motor wires. Okay. So I'm just going to bring out the wires from here. The slots are here. So I'm just going to bring out these wires and I'm just going to do connect them one by one. So now I have these pins here. So these are going to are connected to these pins here. So they are numbered the same as these pins. They are numbered 2, 3, 4, and 5. So I will know that when I connect, let's say this is the left motor of my car. Okay, this is the left motor of my car. I'm going to bring out its wires and I'm going to bring out its wires. And now I'm going to connect the red one, the red one that I know will make my tire move forward if I give positive supply to it is going to be connected to pin number 2. I'm connecting it to pin number 2 of my motor shield that is connected to pin number 2 of my Arduino. Okay, so I'm just going to uh, tighten this up. And similarly, I'm going to connect the black one to pin number 3 here. Whenever all of the motor, there are different types of motor shields, motor drivers available, but they are going to have the similar circuitry. So you don't have to worry about uh, getting a different one than the one I have and then not being able to follow what I'm showing you here. You will be able to follow everything. Okay. So my left motor is connected to pin number 2 and 3 of the Arduino basically. Okay. And then the right motor, I'm going to bring out the wires and I'm going to connect that to pin number 4 and 5. These pins are numbered 4 and 5. So I'm going to connect this to pin number 4 and I'm going to connect this to pin number 5. Okay, yeah, cool. So my motors are connected. Okay, now you'll have to do a bit of wire management here. This is not a really good way to, leave the wires hanging. And you can use zip ties, you can use double-sided tape. I'm just going to place the wire, stick the wires here. Like anything you do, you need a bit of wire management. Okay, like even if you're building your own PC, you're building anything where you're using wires, you just need a bit of clean surfaces so you know what is connected to what. Now, this is not good, but it is doable for now. Now, my motors are connected to pin 2, 3, 4, and 5 of the Arduino. We know that much. What about IR sensors? So for that, let me zoom in here again. Yes. Okay. So you see there are these pins here. They are attached so that we can use IR sensors to connect these pins to our IR sensors pin and collect the data from IR sensor and then communicate that to our motors. So we are going to connect our, so you see all of these pins, there are three pins here. There are three pins here, and there are three pins for each of my IR sensors. So we have to just attach the pins in order. So there is a power supply pin, 5 volt and ground, that are going to be attached to the power supply pins of my IR sensor. And then there is a data pin that is called, so all of these are printed on the circuit. I'm not sure if you guys are able to read what's written on the circuits. Let me, yeah. Yes. So you see it's written here, data pin of now D7 is pin number 7 is data pin, and this is 5 volts pin, this is ground pin. So all of these are written on the circuit, and same is written on my IR sensor here. So when you get these boards, you will be able to, once you read what's written on them, you will be able to know which wire needs to be connected to which wire, which pin needs to be connected to which pin. So I'm just going to connect left sensor. So this is my left sensor, this is my right sensor. Yeah. I'm going to connect my left sensor data pin to pin number 7 of the Arduino. So I'm just going to use some of the wires here. So I'm just going to use the data pin of my IR sensor to data pin of Arduino here. Okay, and then use two more pins to. So this is ground that goes here, and then this is 5 volts that will supply power to my IR sensor that is supplied from here. These pins are numbered. So I'm just following the numbering rule. That's all. Just ensure that you follow the proper numbers and everything will be fine. Yeah, I just need three more wires. I don't need anything more. So yeah, I'm just going to attach the numbers, the pins accordingly here as well. So data pin, it's a gray wire data pin. So right sensor I'm attaching to pin number 8. I'm telling you these numbers of the pins because they're going to be useful when we start coding. Okay. So good. If pin breaks, you can always find more pins. Everything, all of these circuits, every part is disposable. You can get new parts and replace them. Get a solder iron if you guys know how to use solders, and you can desolder the broken pins and attach new pins. Otherwise, get new circuits. They're easy. These are smaller circuits that are very cheap and very easily available. Now, data pin of right sensor, I'm going to attach to pin number 8 of my Arduino, and then the ground pin and uh, the power supply pin. Just attach them properly. So this is the 5 volts pin that I'm attaching to pin number 8 here, and then the ground pin that I'm attaching here. Okay. Now I already have the code loaded on this Arduino. So I just want to show you first of all how the car works, and then we are going to learn how to write the code. Okay. Why don't I show you the code? So I'm just going to move everything a bit away because I need space for the car to move. I'm just going to put these IR sensors away as well. Now, I'm going to hold this camera for a bit, and I'm going to connect my Arduino. Yeah, here. See, the car is following the path. Okay. Whoa, 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 whoa. Yeah. So it's a very small surface. Cool. I'm going to remove the supply. I'll show you how we are going to code and everything. Don't worry about that. But I just wanted to show you that it works. Everything that we are going to do It works. Okay. Uh, Good. Uh, what are we going to do next? We're going to code. We're going to learn how to code the IR sensor. Okay. So let's do that. So yeah, when we code, so I'm just going to switch my screen now to my laptop screen. But before I do that, so Arduinos come with a power cable, with this cable. This connects to your laptop. This connects to your Arduino's code. So whenever you're coding, to load your code into your Arduino, you have to connect this to your Arduino, connect this to your laptop, and then upload the code. I'll show you how to do that, all of those stuff. So we are going to start now. Okay. Uh, okay. No, nobody missed the coding. I'm going to show you how to code now. Okay, so we are going to start coding now. Cool. So, let me just give you an introduction to what we are going to code, how we are going to code. So, what happens is you guys have been doing Hatch coding on HatchXR, JavaScript coding on HatchXR. A lot of you guys. You guys have been coding HTML on VS Code Editor or uh, similar platforms like Atom as a code editor or VS Code Editor. Now, these Atom or VS Code Editor, they are called IDEs, Internal Development Environments. Okay, you can code anything you want there. So for Arduino also has its own IDE, and you can just Google Arduino's IDE and you can download that. It's free of cost. It's easily available for all the softwares, for all the operating systems, for Linux, Mac, Windows. It's available for all of those. Okay, so what we do is you download Arduino's IDE. I'm going to show you how it looks like, and then we are going to write the code on that. And Arduino is not coded using JavaScript or HTML or CSS. Arduino is coded using C language. There is another programming language called C, just like you might have heard of Python, JavaScript, HTML, CSS. All of these are programming languages. C is another type of programming language, a very code programming language on which like Windows is also most probably coded. Yeah, Windows is coded on C as well. So a lot of stuff is coded on C, and Arduino can also be coded on C. Okay, so I am going to show you how to do that. Now I have my Arduino's code open up here. Okay, and what we are going to do is we are going to start coding. Cool. So when you open up an Arduino's IDE, it will look something like this. Okay. Now, don't worry about all of this written here. Is it too big? I think it's the size is good enough for everyone to read, right? Yeah, the size is good enough for everyone to read. Am I lagging? Somebody's asking on the chat that am I lagging? So tell me if I'm lagging, and I'll try to fix my connection. Otherwise, I think I'm good enough. My connection is good enough everywhere. Okay, so yeah, now this is your Arduino's coding area. Okay, just Google for Arduino's IDE and you will be able to find this. You'll be able to download this. When you open up a blank template, it opens up something like this. So you see there are some lines of code written here. Don't worry about these. It's very similar to JavaScript. A bit. Oh, my camera is off. I should turn on my camera and this will start working again now. Good. Okay. So yeah, my camera should be working now again. Cool. So now you'll see what we're going to do is we're going to code here. So this is your basic editor. Now you have two default functions, just like any language has some default functions, like on Hatch as well. You have some inbuilt functions like those setx, getx, setY, getY. Similarly, uh, so it's called an Arduino IDE. Just Google for Arduino's IDE, Arduino, then space, capital I, capital D, capital E. It's called internal development environment. And you will be able to download this. Okay. Yeah. Uh, Good. So you have my camera should be on. Yeah, my camera is on. Okay. Uh, Good. Okay. So you have now in JavaScript, what do we do is we define functions using the keyword function. Yeah, we define functions using the keyword function. Okay. So what's going to happen here is in C and in a lot of other languages, we define a function using the word void. So we have two default functions written here, setup and loop. What they do is loop is basically like the function on hatch called timer. Loop is a function that by default runs again and again on its own. You don't have to call the loop function. It will on its own run again and again and again and again. Okay. And um, if my camera is getting off, I think we can ignore the camera for now. Okay, I'm going to delete my camera. I don't think my camera is turning off. It's just not able to. Yeah. Uh, just ignore the camera. You guys can see the code. We are going to work with the code. This is actually Windows problem. Don't worry about it. So I'm just going to see if the camera is working for another. Yeah. Okay. So what we're going to do is I was telling you about setup and loop function here. So setup function is a function that runs at the very beginning of whenever your Arduino starts running, and it will run only once. So whatever you write inside the setup function is going to run only once. Okay. And then inside the loop function, everything runs again and again and again and again. Okay. So we are going to start writing our code. So before we write anything inside our setup and loop function, what we need to do is we need to first of all define the pins. For whenever you start coding on Arduino, we have to define our pins. Okay, so we have to define them just like we define variables in other languages. So I'm going to define the pins as a constant. Const int. So the way to write it. So I'm defining a constant variable which has a value type of integer, and then give it a name. So I'm going to say sensor, give it a name. So I'm just going to define sensor left. Okay, and I know that left sensor is yeah. I'm just going to remove this thing from here. Okay, so I have to write the pin number. So I have to give all the pins that on which we have attached something pin numbers. Okay. So we are defining variables right now. We are giving a name, a variable name to each of the pins that we have connected something to. So pin number 7, I know that I have connected it to the left sensor's data. So the way I'm so I can the way you define in variables in JavaScript or other languages as well using int, var, let. So similarly, I'm defining an integer variable, which is a constant type. So I have to write it like this: const int, then give it a name. So I'm saying sensor left is equal to 7. Okay. So this is the pin number, and then pin number 8 is what? Pin number 8 is sensor right. I know that I have connected it to pin number 8, so I can just give it a name, sensor right. Okay, good. So pin number 7 and 8 are defined. Now I also need to define the motors because we have connected. Remember, I told you we have connected pin number. We have connected. Yeah, we have connected pin number 7, 8 to sensors, and we have connected pin number 2, 3, 4, and 5 to uh, yeah. Uh, why are you guys spamming? Who cannot see the code? Can you guys not see the code? I can see the code on the YouTube screen that I'm viewing, and everything is visible here. Some of you are saying that you guys cannot see the code. Is that true? Why are you guys spamming, guys? Don't spam. Hmm. I will show you where you can code all of this again. Don't worry. Uh, okay. So we defined sensor left and sensor right pins. Okay. Now we know that our motor pins are connected to pin number 2, 3, 4, and 5 for our uh, motors left and right. So I'm going to define those pins as well. So I'm just going to say left motor, motor left. Now red and black wires, right? So red wire is connected to pin number 2, and so I'm just naming these according to whatever I want. How I know is what I know is going to make sense to me. So motor left black is connected to pin number 3. Oops. So I'm going to define right motor spin as well. So right motor, motor right, red wire is connected to pin number 4, and motor right pin, it's a black wire is connected to pin number 5. Okay, cool. Yeah, so I defined all the pins. Okay, so now, okay, one thing we need to understand is Arduino is a very basic computer. It doesn't know what's input, what's output. Like on your laptop, you know that your laptop or your desktop, it knows that your basic keyboard, your keyboard is an input device. It knows your laptop knows it has to collect input from your keyboard, and your laptop knows that it has to display output on the monitor, right? But your Arduino doesn't. So Arduino has all these pins, all these ports, okay? But it does not know that which of these ports are input or output. Okay, so in your setup function here, we are going to define the modes of these pins. Okay, so we know that we have to take input from the sensor data, from the sensor pins, and we have to provide output to the motor pins. So we just the command to do that is you're going to write pin mode, pin mode, and then a pair of round brackets, then the name of the pin. So left, sensor left, oops, yeah, sensor left, and comma, and I know it's an input pin, so I have to say that it's an input pin. Okay, and similarly, I say I have other pins. So I have sensor right pin, that's also an input pin. Then I have motor left, right, motor left, red wire, that is an output pin. So I have to define it to be an output pin. Okay, Control C, Control V, the red, black, all of those are output pins. Okay, so you have to define them to be output pins. So pin mode for motor right, red wire is also output, and pin mode for motor right, black wire is also output. Okay, so we defined our pin modes. Now, what are we going to do with our loop function? So we are just going to say so see, what did we what did we remember? What did we learn? We learned that when my left or right sensor is facing a white surface, its diode is it's going to have some data, right? Because the light is reflected back to the IR sensor. But when my one second, let me come back to my uh, this thing here. Yeah. So yeah. So what I was telling you was, we know that if the sensors, if both of these sensors are facing the white surface, it's getting some data back. Okay. So it's getting some data back. So pin number 7 and 8 are going to be having some data, right? But if any of these sensors are facing the black surface, that is not going to have any data. Let me show you. Let me show you. Let me turn this on. Yeah. So see, you guys can see this. Yeah. Look at this. Look at this LED and this LED. This IR sensor is facing a. It's glowing here and it's not glowing here. You can see a green light, a dim green light that turns on and off. See that? Yeah. So what's happening is this, because it's facing a white surface, it is turned on. The data pin is turned on. Okay. And same goes for this left sensor. But the moment any of these sensors, see, the left sensor right now is facing a black surface. So its data pin is turned off. Okay. And same goes for this sensor here. So right sensor, when it faces a black surface, its data pin turns off. See, and when both of them are facing a white surface, both of them are turned on. And when both of them are facing a black surface, both of them are turned off. Okay, so that we know the behavior of uh, the IR sensors data pins. So let's go back to our code editor, and what we are going to say is in our loop function, we are going to say we are going to use if else statements just like we do in JavaScript or HTML, CSS. Okay, just like we do in JavaScript. So we're going to say if and sensor left. Okay, sensor left is equal to high. High means it's turned on. If sensor left is getting data back. Okay, and sensor right double equal to low. It means low means it's not getting any data back. Okay, high is basically it is the LED is turned on, the green LED that you were seeing, and low means it's not getting any data back, so it's turned off. Okay, so sensor right is low. So when remember here, let's come back to our window here. Okay, so see, I have both of these LEDs are on. It means the path is in the center and it can move forward, right? If if my left sensor comes along the black surface and the right one is on the white surface, it means what? It means my robot has to turn to the left side. So if left is off and right is on, then turn left. Yeah? And same goes for right. If the right is off and left is on, it means turn right. Okay? So that's what we are going to do in our code. Okay? So we are going to say if left is on and right is off, then we are going to define a turn left function. Sorry, turn right. So right is off, na? Right sensor is off. So I'm going to define a turn right function and I'm going to calling this function here. Okay? And else if now sensor left is low and sensor right is high, okay? So left is off and right is on, okay? Then we are going to define our turn left function. And so when left is off, turn to the left side, okay? And otherwise, I mean, if both are off or both are on, then move forward. I'm going to define another function called move forward, okay? And then see, loop function is on its own going to run again and again. So we don't have to worry about calling the loop function. We just have to now define turn right, turn left, and move forward functions. So how are we going to do that? We are going to create our own functions just the way there are two double equal to's because I'm comparing. Two double equal to is a comparing operation. Okay. In programming languages, you use two double equal to's to compare the left value and the right value. Okay. And if you use single equal to, it means the right side value is being assigned to the left side value. There's a difference. Okay. Cool. So now I was telling you we are going to define our own functions of turning left, turning right. We just have 5 more minutes and we are done with today's class then. So we are going to define turn right, turn left, and move forward function. So I'm saying move forward. I'm defining a move forward function. So I do that by writing the keyword void. So we write void whenever we want a function that is not returning anything, that is only performing a set of activities. Just like in JavaScript, what do? You start a function with the name function and give it a name, right? So rather than using the keyword function in C, what we do is we use void. And if your function returns something, then I can type the declaration of whatever its return type value is. Let's not worry about that. Let's just learn how to write this code. Void move forward, and a pair of round brackets, curly brackets. Inside this, you write what's going to happen to make our car move forward. So for making it move forward, what do we need to do? We need to motor. We have to tell our Arduino to give the red wires of both the motors high voltage and the black wires of both the motors low voltage. Okay, so we have to tell our Arduino to give values. Okay, so to do that, oh, I'm so sorry. Oh, fine. So yeah, we are going to correct. I made a mistake. I will correct that later on. Sorry. So we are going to tell our Arduino to write. So to give the red wires of both the motors high value. Okay, the command for that is digital write. So this means my Arduino is going to supply voltage to some voltage to whatever variable we are telling here. So digital write motor left red wire high. So it basically means the motor left red wire is going to get high voltage. Arduino is going to write high voltage on the red wire. Okay, and same goes for, so the black wire is going to have a low voltage for left motor. When for both the motors, we know that if the red wires have the high voltage, then they are moving forward. Okay, so we just write the code now. Digital write for right is high, and digital write for right motor black wire. 1 second, guys. Uh, 1 second. Yeah. So digital write, motor write, black wire to low. Okay, good. So this means that the red wires of both of our motors are getting higher voltages than the black wires, and as a result, what happens is uh, the motor turns our wheels in the forward direction. Okay, we are going to now similarly we are going to write the functions to make our motors move in the turn in the left and the right direction. How are we going to do that? So here, see, to make my car, to make my car, oops, sorry, 1 second. Yeah, so cool. It's yeah, um, focused. Cool. So to make my car turn to the right side, what's happening? If this motor is stopped and only this motor is turning, see my car is turning to the right side. Yeah. So left motor needs to move forward while the right motor is stopped. Then my car is turning right. And similarly, to turn it left, the left motor stops and the right motor turns. Okay. So we are going to do that in our code. We are going to write a function void turn right, and to make our car turn right, what we have to do is we are just going to say motor left is high on the red wire and motor left is low on the black wire, and then we are going to say motor right is completely off. So motor right, red and black both are low. Okay, cool. Now this will make my car turn right. Okay, and similarly to make the car turn left, we are going to turn off our left motor. So we are going to say red and black both wires are getting low voltages. So it's not turning at all. And my right motor is having high voltage on the red wire and low voltage on the black wire. This will turn my motor, this will make my car turn to the left sides. Uh, so we have move forward, turn right, and turn left. Cool. Now I made a small mistake here. So this is the way you would write it in JavaScript, the loop function. Okay. The if-else statements. If sensor left double equal to high, we don't, because it's, I forgot it's an Arduino. So Arduino, so just like you, we are saying Arduino to write values because the motor left R, motor left B, motor right R, motor right B, they are output terminals, right? We have defined them as output ports here. Similarly, we have defined sensor left and sensor right as input ports. So Arduino has to read the data from it. Okay. So if we can't write it like this, we have to say digital read. Okay. It has to read the data. Just like it's writing the data for left and right values. I'm going to show you guys here. So I have the similar code written here. See, oh, I'm not sure if you guys can see this or not, but sorry, I'll just show you right in this. Okay, so void loop. digital read the data on sensor left. And if that is double equal to high, and digital read. So my Arduino is going to read the value of left and right sensor with these commands. You can't just simply say variable double equal to low or high. Cool. And then the same thing here. Digital read, sensor left is low and sensor right is high, then turn to the left. Cool. Now once you have done the coding, so our code is done. Our code is done. Okay. And after this, what we do is, once your code is done, you have to compile your code. So there is a tick mark on the top. You have to click on this and check if your, so I'm just going to line follower. Cool. So it's, see, it says compiling sketch. It's compiling the sketch. There is a, so sensor left was not, yeah, see, I made a mistake. When there is a mistake here, it will give you the error on the console. So it's not capital L and capital R, it's small l, the way I have defined them. And same goes here, small l. Now, if I verify if there are no errors, then it will compile 100% without any errors. It will tell you that there are no errors. So you have to, first of all, ensure that your code has no errors. Okay, so let it compile a sketch. Yep, cool. So your sketch is compiled. Now what you do is you connect your Arduino using the wires, using the connector wire that I showed you, and then you upload. You see there is this button here. You upload the code onto your Arduino. Once you have uploaded, you will say, so before you upload, what you have to do is, so when you connect an Arduino, I'll show you. I'm connecting my Arduino right now. So I am going to use this. I'm going to connect my Arduino, and yeah. So once you are connected to your, once you have connected your Arduino, you have to go to Tools and select your board. First of all, which Arduino board you're using, because there are lots of types of Arduino board. So you have to say, I'm using an Arduino Uno board. So I have to select that board, and then you have to select the port to which the USB port to which your Arduino is connected. So it will give you the options whenever it detects an Arduino, and it tells me that my Arduino is connected to this COM3 port. So I just select that. You have to define both of these, and then you have to click on upload. And see, it's uploading and done uploading. Once it's uploaded, it will say done uploading. After that, all you have to do is run your code. So see, my Arduino's code was uploaded. I'm going to remove this power supply. I'm going to connect my battery. And see, it's, I know it's working properly because when I am putting it, see, I have my iPad there, so I don't want to destroy that. But even let's make it follow this. See, following. Cool. Done. Okay. One last thing. I told you guys, if you guys don't have the parts, then we can make this on Hatch as well. So let me quickly show you how is that possible, and then I'm going to we are going to end this video. Okay. So I'm going to open up. A Hatch link. Give me 1 second. It's opening up. I'm so sorry. This has taken so much time, but I think we are almost done now. So we are at scene 2. We have yeah. Let me good. So you guys must be seeing my hat screen right now. Yeah, you guys must be seeing my hat screen right now. I'm just going to open up. Where is my mouse? Wow. Okay. For some reason, my mouse is behaving weirdly. That's nice. That's weird. Okay, I'm just give me 1 second. No, not a scene. Escape. Okay, cool. So yeah, I'm just sharing my entire screen with all of you now. Okay, done this. I'm just going to open up my projects here. Wow, I'm so sorry. Everybody's getting bored. They're leaving. We are done. We are done. Just 5 more minutes. So if you guys don't have the parts, then what you can do is I'm just going to open this up. If you guys don't have the parts, then you can code the exact same thing as a VR robot on Hatch. You can see I have a car here, and in the car I have defined. I have what I have done is I have two sensors. I have added two boxes that can act as sensors, and then I have just added written the code of how I want the car to move. And you see, if I run the script, my car is going to move on its own. I'm not making the car move, it's moving on its own. You can see my mouse is moving freely, and you see my car is following that black line that it's seeing. And I have written console to tell me when it's turning left or right. So it does that. Yeah, cool. So perfect. You guys, if you guys don't have the parts, still the reason I wanted you guys to follow the video is so that you guys can learn the code, so that you can even code the entire thing, entire logic on Hatch as well. Okay, um, good, perfect. So I'm tired now. We are done with this video. I hope you guys enjoyed learning something completely different from coding, some electronics and hardware part as well. I genuinely like this hardware stuff rather than simply coding. So we are now done with this. Okay, I'm just going to come back to the screen for 2-3 more minutes. Okay, so things we have. See, you can build anything. This is a very primitive robot that I just built. You can have, there are lots of competitions on just path following where you have to code your robot so that it can detect path faster and move faster. Like how efficiently and how faster you can. There are lots of line following robot codes. Uh, that can make your like move in a very fast way, in a very efficient way, and detect path zone. What else you can do here? We can add obstacle avoidance. I'm just going to show you something. So I have a part here that is called, yeah. So this is called an ultrasonic sensor. Okay. I hope it's visible. Yeah. This is called an ultrasonic sensor. What this does is this. Just like infrared sensor, this infrared sensor emits light waves, this emits sound waves. So one of these emits sound waves, and then when the sound is reflected back, it's detected by the other one. So with the ultrasonic sensor, you can determine the distance between your car and other objects, and make record the robot such that it avoids obstacles and moves on its own. Okay, so you can do that. You can. There are lots of other modules as well. Let me show you something. have more circuits here. I can show you some more stuff. I have a Bluetooth module here somewhere. Give me 1 second. Yes. Yeah. So I have this is a Bluetooth. So I'm just going to put this. Uh, this is a Bluetooth module. This connect this, uh, and then you can communicate to your robot using your phone or any wireless controller, any wireless Bluetooth controller, and you can make your car move forward, backward, left, right using your phone. You can do a lot of stuff. These are very basic stuff I'm showing you that you can start your robotics learning experience with, and then move on to make lots of more advanced robots. You can add AI code, you can add neural networks to your code so that it moves on its own. Lots of stuff to make it, a self-driving robot car. So yeah, we are done with the video now. Going to stop bore all of you. Let's next week again. Niharika ma'am is going to take the session, and she's going to show you guys something really cool. And after that, you guys tell me what do you want me to cover in the week after that. So 2 weeks after today. Do you want to cover obstacle avoiding robot, or do you want to cover something cool on Hatch that you guys can code with me? And we will do that. Okay, you guys can just go to your Discord, K12 TV Discord, and so if you guys are on the K12 Discord, just go to the K12 TV channel and tell me. I'm there. You can tell me. You can message. What exactly do you guys want to learn? And we will cover the topic. Cool. Bye. I'm going to end.